Welcome to this video session. My name is Samuel Chukwuemeka, as usual. In this video session, we shall discuss complex numbers part 3. Here we shall multiply and divide complex numbers. And when we do that, we want to leave our answer in standard form. Please, before you view this video, it is highly recommended that you view the videos I did on polynomials. It is very important that you view the videos I did on polynomials, especially as regards multiplying polynomials, when you have to multiply a monomial by a monomial by a binomial, and when you have to multiply two binomials, okay? And you can use FOIL method, the FOIL method. So when we multiply complex numbers, we just follow that order. The way we just multiply polynomials is the way we multiply complex numbers. Now, bear in mind, okay, the another video that I would recommend that you view is the complex numbers part 1 and part 2. Complex numbers part 1 and part 2. Bear in mind that when we did powers of I, we noted that I squared is -1, you know. I is square root of -1, so I squared will be square root of -1 all squared, and that gives us -1. So this is what we should note. Okay, let's go ahead and start. Okay, just like we multiplied monomials, just like we multiplied monomial and binomial, just like we multiplied binomials, two binomials using the FOIL method, that is the way we do for complex numbers. We just have to keep in mind this knowledge also. All right, let's solve the questions on the right. Number 1, we have 7i times -4i. If I want to kind of break it down very well, if I want to simplify it very well, this will be 7 times I times -4 times I. You see how I dissociated it? I dissociated it. Then what I will now do is to combine the real numbers together and then the pure imaginary numbers together. I'll multiply them. 7 times -4 times I, right? And that will give you -28 times I squared. You see, -28 times I squared, because I times I is I squared. Now remember that our I squared is -1. So this is -28 times -1, and that will give us 28 as the answer. Okay. But they want us to leave it in standard form. So because they want us to leave it in standard form, this will now be 28 plus 0i. Remember, standard form is what? A plus bi. So the real part is 28, the imaginary part is 0, and the pure imaginary number is 0i. And the imaginary unit is I. Okay, not I now. That is small I. All right. Question 2. I would like you to pause the video here and try it on your own before you do it. Before you start it, you play it again. This is -5i times -5 minus 8i. So here, I'm just gonna go ahead and multiply, okay? Now, this is like how you multiply monomial and binomial. So take this one, multiply this, then take this one and multiply this. So this is -5i times -5, you keep it, then -5i times -8i. Okay? So -5 times I times -5. -5 times -5 give us 25. 25 times I gives us 25i. So this is 25i. Then this will be -5 times -8 is 40. 40 Then I times I is I squared, right? So this is 40I squared. Are you with me? Which is 40 times what? -1, which is -40. You see that? So please just write it as is. Okay, you see this? Write it as is. So the answer will be what? 25I minus 40. Answer. That is as simple as that. 25I minus 40. Okay? Number 3. We have -4 minus 2I times -7 plus 6I. So the way you do your FOIL, if you want to use FOIL, just the way you do your multiplying two binomials, that is the same way you do here. Okay? So this is -4 times -7. If you want to do FOIL, that's fine. First, outer, inner, last. If you want to use that, that's fine. Okay? -4 times -7, then -4 times 6I. So you finish using -4. You continue with -2I times -7. Okay? And then -2I times 6I. This is like first, outer, inner, last. You want to do that? Okay. So what is it going to be? -4 times -7 is what? 28. Because negative times negative is positive. -4 times 6 is -24I. Right? -2 times -7 is 14I times I is 14I. Then -2 times 6 is -12 times I squared. Okay? Which is -12 times -1, which is 12. So you now get what you have. 28, you now have what? 28 minus 24I, right? Plus 14I, then plus 12. 28 plus 12 is what? 40, right? Minus 24I plus 14I is what? Minus 10I. Okay, minus 10I. So your real part is 40, your imaginary part is -10 or minus 10. Your pure imaginary number is minus 10I. And your imaginary unit is what? You, not I. Okay, don't mind me. It's more I. So that's the way we do it. You know, that's the way we solve it. And sometimes it's kind of good to cross-check to make sure you didn't make any mistake, you know. All right, question 4. (3i times 2 minus I all squared). Okay, you have this, right? Now, in this case, just write it in expanded form. Go ahead and write it in expanded form, and you can do it 2 at a time, okay? So this means 3i times 2 minus I times 2 minus I. That is what it means. 3i times 2 minus I times 2 minus I. So you can kind of do this first and then multiply it by this, or you do this 2 first and multiply it by this. It doesn't matter, okay? So I'll just go ahead and do it like I said. Let me do this first. 3i times 2, then 3i times -I. You see, I'm using the first one to multiply every other term. That was the way I explained it in multiplying polynomials. Okay? So 3i times 2 is 6i, and then 3i times -I is -3i squared, which is -3 times -1, which is 3. So here we have 6i plus 3. Okay? Then times 2 minus I. Times 2 minus I now. We've got this. We now multiply it by 2 minus I. So what do we have when we do that? We have 6i times 2, then 6i times -I. You see, I will first of all write it out before I write what it means. Okay, that was the way I did it with polynomials. Then 3 times 2, and then 3 times negative I. So this is what? 12I, and this is what? Negative 6I squared. Negative 6I squared will give you negative 6 times negative 1, which is 6. 3 times 2, 6, and 3 times negative I is negative 3I. So we have 12I plus 6 minus 3I. 12I minus 3I is what? 9I plus 12. 9I plus 12. Or, if you want to write it in standard form, it will now be 12 plus 9I. Okay? Now, some folks might ask me, okay, what if I do this first and then multiply it by 3I? We can do it. It don't matter. Let's do it. Let's do it. Assuming we have 2 minus I, 4 times 2 minus I, this will give 2 times 2, which is 4. Okay, let me first of all list it out before I solve. 2 times 2, 2 times negative I times 2, and then negative I times negative I. So this is 4, this is negative 2I, this is negative 2I. Negative times negative is positive, I squared, which is minus 1. So this will be 4 minus 2I minus 2I minus 1. 4 minus 1 minus 2I minus 2I, which is 3 minus 4I. Now this 3 minus 4I, I use 3I to multiply it. I now come and multiply 3I. If I now come and multiply 3I times 3 minus 4I, that will be 3I times 3, and then 3I times negative 4I. And this will give us 9I, and this will give us negative 12I squared, which is negative 12 times negative 1, which is 12. So you now have 9I plus 12, or 12 plus 9I. The same thing we got here. You see, it is the same thing we got here. Okay. Question 5. Question 5. Square root of 7 plus I times square root of 7 minus I. Please, that reminds me, before you view this video also, view the video on factoring by difference of two squares. Because this is a clear case of difference of two squares. You know, you can use FOIL to do that, but it's waste time. It's gonna waste time, right? We can still use FOIL here though. But you know, other cases of difference of two squares, I just don't want to waste time. I want to do a difference of two squares. And that will be, and that is the same thing I will use for when I go to division, which I will soon be getting very soon. You know, because remember, yeah, view the video on the difference of two squares, please. It's important. So this gives us root 7 all squared minus I squared. That's what it gives us. Root 7 all squared is 7 minus 1. I squared is minus 1. So this is 7 plus 1, which is 8. The answer is 8. They want you to leave it in a standard form. It will be 8 plus 0I. Okay? You see, this saves us time than coming to do the FOIL method with 7 times root 7, root 7 times negative I times root 7, and then I times negative I. This will give us 7. This will give us negative I root 7. This is I root 7. And then this is negative I squared, which is negative times negative 1. Negative 1 times negative 1, which is 1. So this will be 7 minus I root 7 plus I root 7 plus 1. This will cancel out 7 plus 1, which is 8. Yeah, we are going to use this when we do division, when we talk about conjugates. Okay, rationalization of complex numbers. So when you see this stuff, it's easier to use difference of two squares. If you want to use this, that's fine. but I would use difference of two squares right away. Okay? And you see, this gave us a real number. We will get to that soon in division. Okay, that is question 5. So, yeah, view my videos on factoring by difference of two squares. Yeah. The next one is question 6. 7 minus 4i times 7 plus 4i. So this is different. This is a clear case of difference of two squares. These are conjugates. Okay, so this is 7 squared minus 4i all squared. So this is 49 minus 16i squared, which is 49 minus 16 times minus 1, which is 49 minus minus 16, 49 plus 16. Okay, and that is 65. Okay? 49 plus 16, which is 65. Just know that I squared is minus 1. So some people will skip this step and just write 49 plus 16. From here, they jump to here immediately, because I squared is minus 1. Okay, that's it. If you want to use FOIL for that, that's fine. Alright, now let's come to division of complex numbers. Before we talk of division of complex numbers, just like when we did radicals, we talked about rationalization of radicals. We don't want an irrational number to be at the denominator. The same thing with complex numbers. We don't want a complex number to be at the denominator. We want to rationalize that complex number. Rationalization of complex numbers. So what it means is make the denominator of the complex number to be a rational number. Rationalization. Now I don't know, some textbooks might write it as S, but I think the right thing is C. Now, rationalization of complex numbers. You want to make the denominator of the complex number to be a rational number. That is what you want. Okay? So, and how do you do that? How would you do that? By multiplying by the conjugate of a complex number. So now, the next thing you ask me is, what is a conjugate? So remember, rationalization means making the denominator of the complex number to be a rational number. Now, how do you rationalize? By multiplying the numerator of the complex number and the denominator of that complex number by the conjugate of the denominator. Conjugate of a complex number. Okay? So this is defined as that complex number whose product with the original complex number okay, gives a real number. So now when we talk of conjugates, we mean like the conjugate of a complex number is, what is that complex number by which you will multiply it with the main complex number to give you a real number. Okay? Because we know, why do we do this? Because we know that the product of a complex number and its conjugate is always going to be a real number. The product of a complex number and its conjugate is always a real number. Product of a complex number and its conjugate is always a real number. Okay? So what we want to do is when we have a complex number that is like a quotient, okay, that's the numerator is a complex number and the denominator is a complex number, but mainly we are looking at the denominator being a complex number. We want to make that denominator a rational number, right? And by how do we do that? By multiplying both the numerator and the denominator by the conjugate of the denominator. Okay? By the conjugate of the denominator. So let's go ahead and we have some division problems here. Now, before we start solving the examples on division, let's kind of look at conjugates. Complex numbers and then conjugates. Now, another thing with conjugates is that they differ in sign. Their imaginary numbers, their pure imaginary numbers differ in sign. So you can also say that the conjugate of a complex number is that complex number that differs in sign, whose pure imaginary number differs in sign with the pure imaginary number of the original complex number. You can also say that. Now, if we have something like I as the complex number, the conjugate is negative I. If we have negative I as the complex number, the conjugate is I. If we have A plus BI, the conjugate will be A minus BI. Okay? If we have A minus BI, the conjugate will be A plus BI. If we have negative A plus BI, the conjugate will be negative A minus BI. If we have negative A minus BI, the conjugate will be negative A plus BI. Okay? So the thing is that you look at the pure imaginary number, it differs in sign. Here the pure imaginary number is BI, here is negative BI. Here is negative BI, here is BI. So you look at only the pure imaginary numbers. If it differs in sign with the original complex number, that's with the pure imaginary number of the original complex number, then it is the conjugate. Okay? So with that in mind, I think we can begin to solve questions on division. So number 7, 5i over 3 plus 7i. Now, we are not bothered with the numerator. We are bothered with the denominator. And why do we always want denominator? You know, the person that is big and the person that is small, you want the person that is big to stay at the denominator, so that the person that is small will be on the numerator. You know, you want a real number, you want a rational number or a real number to be at the denominator. You don't want a real number or rational number to be on top and a complex number will be at the bottom. Okay, you don't want complex numbers to be at the bottom at all. You want real numbers to be at the bottom. Okay? That's what you want. Yeah. So you want actually rational numbers to be at the bottom. That's why we say rationalization. Okay, you want rational numbers to be at the denominator. So now we look at this. What is the conjugate? What is the conjugate of the denominator? 3 plus 7i. That will give us 3 minus 7i. So what we do now is to multiply both the numerator and the denominator by the conjugate of the denominator. So you see that? We multiply both the numerator and the denominator by the conjugate. And this is simply like, it's as if you're multiplying 1. You know, it's as if you're multiplying by 1. So now when we do this, 5i times 3 is what? 15i. Then 5i times negative 7i is what? Negative 35i squared. All over, you can do this as difference of 2 squares. 3 squared minus 7i all squared. Okay? So this will give us what? 15i. Now, this I squared is minus 1 times negative 35 is plus 35 all over. This will be 9 minus 49i squared. You see that? So this will now be what? 15i plus 35 all over 9 plus 49. Okay? And that will give us what? 15i plus 35 all over what? 58. See that? Now we can simplify this more. We can factor it out. If you leave your answer like this, it's not bad, but you know, you can still factor this out. So what is common there is 5. 5 into 3i plus 7 all over 58. Now, as you can see, this 58 is now a rational number. The 58 here now is a rational number. So we have achieved our aim by making the denominator a rational number. Okay? All right. The next question, let's solve more. Number 8, we have negative 3i over 3 minus 5i. So what is the conjugate? The conjugate of 3 minus 5i is 3 plus 5i. So this means 3 times 3 plus 5i all over 3 plus 5i. Okay? And this will give us negative 3i times 3. Negative 3i times 3 is what? Negative 9i. Then negative 3i times plus 5i is negative 15i squared all over. This is difference of two squares. 3 squared minus 5i all squared. Okay? So this will give us negative 9i plus 15 all over 9 minus 25i squared. And this will be negative 9i plus 15 all over 9 plus 25, okay, which is negative 9i plus 15 all over 25 plus 9 is what? 34. Okay? Now, something can, 3 is common here, and if there's a leading negative, whenever there's a leading negative, you factor it out. Whenever there is a leading negative, you factor it out. So this will be negative 3i, negative 3 is common. Then this is 3i minus 5, okay, over 34. Now, and this is the final answer. Okay, but look now, they told us to leave this in standard form. They told us to leave it in standard form. So if you're asked to leave it in standard form, then we don't need to factor out like this. We do not. When we have to leave it in standard form, then this will be negative 9i over 34 plus 15 over 34. Okay? And then this will now be 15 over 34 minus 9i over 34. So with the former one we did, with number 7 that we did, you can now leave it in standard form. You know, you don't need to factor it out. Yeah, if you're asked to leave it in standard form, then you don't need to factor it out. You just leave your answer. Like, you break it up in fractions and leave your answer like this. Here, the real part is 15 over 34. The imaginary part is negative 9 over 34. And the pure imaginary number is negative 9i over 34. And the imaginary unit is IU. Okay? So you can now put question 7, you can put it in a, you can put question 7 yourself in a standard form. Okay? So the rest of the ones we just have it in standard form. Yeah. But if you are not asked to leave it in standard form, then it's good to factor it out. If there are common factors, you factor it out. Okay? Question 9. You have 2 minus I over 2 plus I. So what is the conjugate of 2 plus I? It's 2 minus I all over 2 minus I. You multiply both the numerator and the denominator of the complex number by the conjugate of the denominator. So this will give us 2 times 2 is 4. 2 times negative I is minus 2I. Minus I times 2 is minus 2I. Minus I times minus I is plus I squared. All over 2 squared minus I squared. So this will be 4 minus 4I minus 1 all over 4 minus 1. Okay? 4 minus 1. So this will give us what? 4 minus 1 is 3. 3 minus 4I all over 4 plus 1. So this will give us 3 minus 4I over 5. And that will give us 3 over 5 minus 4I over 5. And that becomes our answer. Okay? Alright. Next one. Question 10. Sometimes when you do math, you want to double check to make sure that you got it right. Question 10. We have negative 2 plus 5I over 7 minus 2I. What is the conjugate of 7 minus 2I? That is 7 plus 2I. Okay? So we have times 7 plus 2I all over 7 plus 2I. So this will give us negative 2 times 7 is negative 14. Negative 14. Negative 2 times 2I is negative 4I. Plus 5I times 7 is plus 35I. Then plus 10I squared all over 7 squared minus 2I all squared. So this will give us negative 14 minus 4I plus 35I is what? Is plus 31I, then minus 10 all over 49 minus 4I squared. Okay? This will now give us negative 14 minus 10 is what? Negative 24 plus 31I all over 49 plus 4, which is negative 24 plus 31I all over 53. Okay, which is negative 24 over 53 plus 31I over 53. And that becomes your answer. Okay, now what if we have this? Because some students get confused here. What if we have question 11? What if we have negative 7 minus 2I? Here. So this will be times, what is the conjugate here? Negative 7 plus 2I is the conjugate. Okay, because the signs differ with just the pure imaginary numbers. Okay? All over negative 7 plus 2I. So this is what? Negative 2 times negative 7 is 14. Minus 4I minus 35I plus 10I squared all over negative 7 all squared minus 2I all squared. Negative 7 all squared minus 2I all squared. Okay? So this will give us what? 14 minus 39I minus 10 all over 49 minus 4i squared. Okay? And that will give us what? 14 minus 10 is 4. 4 minus 39i all over 49 plus 4, which is now 4 minus 39i all over 53, which will give us 4 over 53 minus 39i over 53. And that becomes the answer. Okay? We have about 2 more to go. And the last 2 are pretty easy. Question 12. 12 over I. Okay, now, you can do this 2 ways. You can multiply by the conjugate times negative I over negative I, because the conjugate of I is negative I. And this will give you negative 12i over negative I squared, which is negative 12i over negative 1, which is negative 12i over 1, which is negative 12i. Okay, this is one way to do this. But you can still do it another way. Okay? Now, when you have a pure, when you have only a pure imaginary number, in this case, this is just imaginary unit, but you can call it pure imaginary number because this is like 1i. Okay? When you have a case of only a pure imaginary number, you can just multiply it by that by itself. Yeah, you can multiply by itself because I times I will eventually give you a real number anyway. You know, I times I will be I squared, which is negative 1. So when you have only a pure imaginary number, you must not multiply by the conjugate. You must not. Okay, so we can do this way. We can also do this as this, 12 over I times I over I. We can do it like that. And this will give us 12i over I squared, which is 12i over negative 1, which is negative 12i. Yeah, it's still valid. Okay, when you have just the pure imaginary number as the denominator, you can go ahead and multiply it by imaginary number, or you can multiply it by that same pure imaginary number. Okay, because eventually I times I will be I squared, which will give you a real number, or a rational, which will give you a rational number. Okay, now the last question, last but not the least, is question 13, negative 12 over 5i. So you can, if you like, to multiply by I over I. If you like, to multiply by 5i over 5i. So it still doesn't matter. You can multiply by I over I. This is negative 12i over 5i squared. Okay? Which is negative 12i over negative 5. Which is 12i over 5. Yeah. Now if you choose, you can multiply by 5i over 5i. But you will still need to simplify it though. Yeah. And yes, that reminds me, if you're asked to now put this in standard form, it will be 0 plus 12i over 5. Okay? I think the other one we got negative 12i. So standard form will be 0 minus 12i. Yeah. Some people will choose to do this by multiplying it by 5i over 5i. Yeah, it will work, but you will still simplify it later on, because this is negative 60i over 25i squared, which is negative 60i over negative 25. Negative divided by negative is positive, so 5 into 25 is 5, 5 into 60 is 12. We still give you 12i over 5, then which is 0 plus 12i over 5. So this is it for tonight. Okay. If you have questions, feel free to ask. I hope you understand it, and you can do the ones in your textbook and the ones anywhere they ask it. Thank you so much, students, for listening, and you have a good evening.